Okay, hi guys. So let's move to the next problem. So this time you drop a mass m from a height h1. So this ball hits the ground and bounces back. Okay. So the contact time with the flow is small t, and rebounds height. Okay, so let's assume here it comes to rest. So this is h2. The question is show that the average net force on the ball is F net n times square root of 2g h1 plus square root of 2g h2 divided by t. Okay, so this problem is not really very complicated. So how do you do this? So the first, I'll try to find what is the speed when the ball reaches the ground. So what is the speed here? Let me put here v1, and it bounces off at the speed v2. So how do you find v1 and v2? I can use the conservation of energy. So I'll use first conservation of energy from here to here. So here we have only the potential energy, because the kinetic energy is 0, because we said we dropped the ball. So the initial speed is 0. If you apply the conservation of energy, you will get the total energy here mgh1, which should be equal to here the total energy. The potential energy becomes 0, so you have only kinetic energy, so which is half mv1 squared. So you can cancel out m and m. So v1 will become square root of 2g h1. And similarly from here to here I can use the conservation of energy. So here the total energy is only, you have half m v2 squared, and here you have only the potential energy, which is mg h2. So from here I can find v2 is equal to square root of 2g h2. So we found the momentum, the v1 and v2. Now we need to find F net. So how do you find F net? I know the equation for impulse. Impulse is equal to F t, which is equal to mv minus mu. Change in momentum is called impulse. So here this F is actually our F net. Okay, and we know what is v1 and v2. So if you substitute, you will obtain this answer. So how do you do that? So F net is equal to mass, m is a common factor, final minus initial speed. So what is the final speed? This one, square root of 2g h2 minus the initial speed is, you see, it is in the opposite direction. So I'll put minus square root of 2g h1. Okay, so, and I have to divide by time. You see here we have time, so I'll divide by time. So from here I can get m square root of 2g h2, minus into minus become plus, square root of 2g h1 divided by t. So this is the force on the ball, the net force on the ball. Okay, so we'll move to the next question. So the next question is about, I mean, we have done very similar problem, right? Yeah, so it is more or less the same problem. I already did this, but anyway, we'll solve this problem. So here you have a graph, force and time, and this is how it varies. Okay, the force varies with time. So this is 10 Newton, and here 10 seconds, and here it's somewhere you have 8 seconds. Okay, 8. The corresponding force at 8 seconds is 4 Newton, and here it is exactly 5 seconds, this point, and here somewhere we'll say, okay, 4. Okay, so this is 4. Well, the question is like this. You have a mass, this is initially at rest. So the mass is actually 4 kilogram, and you apply a force. This force is actually time dependent force. So we already solved this problem, right? So how do you do this? So the first question, the question number 1, the acceleration of the mass. The acceleration of the mass at 4 seconds. How do you do this? How do you find the acceleration of the mass at 4 seconds? 4 seconds mean it is here. Okay, this is our 4. So at 4 seconds, what is the force? Force is 10 Newton. So I can use F is equal to ma, mass time acceleration. So from here, force is 10, mass is 4, time acceleration is a. So from here I can say a is equal to 2.5 ms minus 2. Okay, well, the question number 2. Question number 2 says the velocity of the mass, at 5 seconds. The velocity of the mass at 5 seconds. So how do you do this? Well, so I'm going to use at 5 seconds, you see, at 5 seconds still you have the same force, so the same acceleration. So I can use v equal to u plus at. So I need to find the final speed. What is the initial speed of the system? I told you that is 0. So 0 plus 2.5 times at 5 seconds. Okay, so if you simplify, you will get 12.5 ms minus 1. Okay, it's really very straightforward questions. So we'll move to the third question. So the third question is the acceleration of the mass. The acceleration of the mass at 8 seconds. Okay, what is the acceleration at 8 seconds? So at the 8 second, you see the corresponding force is 4 Newton. So I'll use F is equal to ma. I mean, this question is really super simple problem. Okay, so F is 4, mass is 4 times acceleration a. Therefore, you will get acceleration 1 ms minus 2. And the fourth problem is the velocity of the mass at 10 seconds. What is the velocity of the mass at 10 seconds? So how do you do this? Well, so I'll use a change in momentum, which is we call impulse. I is equal to mv minus mu. We know, we said here the initial speed is 0, so this part becomes 0. The question is, we need to know the final speed, okay? We need to know the speed at 10 seconds. So what is impulse? The impulse is simply, you can find the area under this curve. Okay, find the area under this curve. How do you find the area? So this is 10, this is 5, so you have to add two parallel sides. 5 plus 10 is 15. 15 by 2 multiplied by the height. The height is 10. So this is the area. So area gives you what? I explained this in the first video. The area gives you the impulse. So 15 divided by 2 times 10, which should be equal to what? 4 times v, the mass times velocity. So from here you can obtain v is equal to 18.75 meter second minus 1. I hope you got the idea.